Hello, I'm Charles Scola, and this is ICP number 12. So, the task for this ICP is to find a time series data, for example, a company stock report, create a RNN to train that data and make predictions. So, this forewarning, this ICP took a lot of time. I had a lot of issues with it, and a lot of code in this ICP is not needed, and there's specifically one line that isn't even used or referenced at all. But I'm at the point now where I'm afraid to remove anything through this ICP. Okay, so first off, let's get started. So we have to import all the important things. So everything down here is from the ICP example that was given to us in class. I'm afraid to remove any of them because I removed some that weren't needed and it wouldn't work. I don't know why. It's probably just Colab not working correctly or getting disconnected from the internet. I don't want to risk it anymore, so I keep everything in. What we do import is NumPy, Panda, NumPy because we need NumPy in order for the model to work. Pandas in order to easily export the model. Matplot in order to show our report, and SymPy because we need a specific function. So first off, we're going to read the data. The data I got was from Kaggle, and it's Apple stock. So it looks like this with over 3,000 entries. So the first thing we got to do is we got to reduce this a lot. The only thing that we really need is the close section. So we made another data for another a we made another data point where it's only just the closed sections. And since it's already in sequential order, this is perfect for training. So next we gotta separate the training and the testing. To make it so that the graph is a bit more readable, we had testing set to only about 100, while training was ludicrously large. Well, this is pretty much a good standard. The more training data you get, in general the more accurate that your model is. However, this is really big. So next, this is we have to scale the data first, or the model won't work correctly. So this is the function that we use, the min max scaler. So first, we train the function. We transform the training data using the fit transform, and then we put t into x, and we put t plus 1 into y because it wants you need to for sequential neural networks, you need both the current and data and the next data point in order for it to train properly. So after we do that, we put them into the NumPy arrays, and we also have to reshape it and with the size and with the shape as well. So specifically this code, I've had a lot of issues with this code. Then after that, we could do sequential things. So we have 3 different layers, each with 10 neurons in each layer. Any more, and it gets a bit too complicated. Any less, and I haven't tried it with any less. Honestly, I this works for me, and a low dropout because honestly, I wasn't paying. I just copied this code from the example that we did, and the dropout was low, so I kept it low. It more bigger dropout might be beneficial, but because the stock market is kind of weird, we figure that it's probably beneficial to have at least a small dropout instead of a big dropout. So then we compile it with the mean squared error. I did mean squared error right here instead of calculating the actual mean squared error because it's just easier. Right here, this code is not needed whatsoever, but I'm afraid to remove it because I don't want any errors, even though this will not cause any errors not removing it. I'm kind of paranoid about this code because I spent multiple days trying to fix it. Okay, so now we fit the model. I use 200 epochs because it's not that difficult. Sorry for the phone. And right now, the minimum we end it with a loss of about 0.0435, which is pretty good if I do say so. So now let's input the test data. First we have to do the transform and stuff in order to normalize the testing data as well, and then reshape it again, and the same thing as we did with the training data, and then we can predict it. So in order for the data to read accurately, we have to do the inverse transform function in order for it to be able to show up on this graph. As you can see in this graph, the shape looks pretty identical. However, there's a big drop of accuracy once this huge increase happens. So it's not really accurate. It is precise with shape, but not accurate with the size, if that makes sense. So there's probably a lot more I could have done with this ICP. However, I was having a lot of issues with it. For instance, as you can see right here, I once had an epoch with a loss of over 2,000. And also, I had this graph at one point, and it was at the point now where it works. So I am happy. Thank you for watching, and if I had more time, I would definitely work on this a bit more, but I am running out of time and I have to study for exams.